Hello, everybody, and welcome to another online event for the Materials and Embodied Carbon Leaders Alliance. So this is shining a spotlight on the myths around harvesting and the use of engineered timber. So for those of you who don't know me, my name is Monica Richter. I'm from WWF's Climate and Energy Practice, otherwise known as Regenerative Sky. And I'm also delighted to be the project director for MECLA. So I welcome you all. Before we begin, I'd really like to acknowledge that I'm coming to you from the Gadigal lands of the Eora Nation, which spans the rivers from the Hawkesbury River to the north and the Pean River to the west and the Georges River to the south. We're all on Indigenous land, so I want to pay my respects to elders past and present. Welcome any Aboriginal and Torres Strait Islander people joining us here today. So for those of you who don't know much about MECLA, we are about disrupting business as usual right across the building and construction industry with a focus on upfront and embodied carbon. Think about what and how we design, think about the kinds of materials we use in our buildings, the buildings we live in, the buildings we work in, the roads and the public transport we travel on. We're about aligning with the Paris Agreement targets and the principles of the circular economy. 2023 has been a very busy year for MECLA. We have now over 150 members and continue to build our reach and momentum for speed and scale. So while MECLA is industry-led, it's terrific to see partnerships between industry, government and civil society working together to shape this agenda towards decarbonisation. So now towards the mechanics of this session. We are recording this session. It's a webinar rather than a meeting. We have over 450 registrations. You'll be able to access it at the end on our website. Please we've got both the Q&A and the chat functions for comments and questions. We'll field these throughout the event. And for those of you who are looking for CPD points from the Green Building Council of Australia, please note you can do so. You need to let us know, but you have to remain on for at least 50 minutes to qualify for a CPD point. And as always, we'd like to remind all our MECLA members and attendees of our governance requirements. MECLA does not tolerate any anti-competitive behaviour. We operate in a pre-competitive environment, and if you are aware of conflicts of interest, please do speak up and we'll adjust accordingly. So MECLA, we are about doing, we call ourselves a do tank, and today we're busting some myths about engineered timber. Timber is a beautiful product. It can sequester carbon, champion forest stewardship, supporting rich biodiverse ecosystems and regeneration, and reduce the embodied carbon in the built environment. We use timber in our buildings, and we're tapping into biophilic design, connecting with nature, and something that our senses relish. So this is the beginning of our biomaterial journey as we move forward with the industry. And the MECLA members recognised a few years ago that it would be very helpful to set up a working group on engineered timber. So this event will feature some of the members from that working group. We conducted a survey right at the beginning of our working group and realised there were a few questions and myths circling around the industry that we are hoping will be addressed today. How can architects and specifiers of timber products feel comfortable doing so and not get caught up in using old growth forests? Can engineered timber be truly sustainable? Head contractors saying that they want to use Australian engineered timber in buildings, but they're not necessarily confident that there's enough supply in Australia. There are risks associated with timber buildings, fire risks, and won't that increase insurance costs and make it prohibitive to use? And also, how do you measure carbon in forests and wood products? So we've had plenty of discussions in our working group around these issues, and now it's time to share some of these insights with you. So the session will be chaired today by the MECLA Working Group Chair, Stephen Simpson, who's Design Director at MELFA International. So Stephen's an architect by profession, very passionate about good design, project design management professional, over 25 years experience in design and construction across residential, education, retail, commercial mixed-use projects with an emphasis on management aspects of project creation. Stephen recently joined MELFA International as a design director, and he says that he's very happy to be part of a business promoting engineered timber. And they've got 2 built form 7-story projects completed in the last 7 years. Abio Northwest and the Bond Northwest. So I'm delighted to have you, Stephen, here, that we're finally at this point where we can share some of our knowledge, and I'll hand it over to you. Cheers.
Thanks, Monica. I hope you can all hear me okay. Thanks for that lovely introduction. It helps soften the blow of landing at the head of our myth-busting session today. It's really great to see that we've got over 400, maybe 450 industry folk joining us, attending today's session. So I really encourage you to listen in. And if you haven't already thought about questions, get those at the ready for the back end of this session and add them to the Q&A template on Zoom. As excuse me, as Monica touched on, the MECLA spotlight on timber myth busting takes aim at the misperceptions around engineered timber. Engineered timber is a regenerative resource, sequesters carbon and offers a low embodied carbon solution to decarbonisation challenges faced by the built environment. As such, it is expected to increase uptake over the coming decades. And while it has an immense potential for application in our lower carbon projects, the sourcing of responsible timber in Australia is not without its own challenges. Timber has a diversity of use cases and is already commercially used both structurally and in fit-outs. However, there are still many barriers that the working group and I split ourselves into subgroups, and we've started to look at and focus on these areas in Australia construction. Often these misconceptions are around, does sustainable forestry still cause deforestation? Are there supply challenges, as Monica alluded to? What is the fire risk and the insurability of a timber building? Is the carbon stored in wood emitted at end of life? And biophilia, what is it? How does it make us feel? And what are the benefits? You'll hear today these and more. But before I introduce our first speaker, just some minor housekeeping. We will be sending out a poll at the midpoint session for everyone to partake in to get a feel around industry and your view on engineered timber. And as I mentioned, any questions that you do have, please add them to the Zoom Q&A tab. Anyway, let's get going with our first speaker. I'd like to introduce to you Matt De Jong, Sustainability Manager at Responsible Wood, Queensland. And he will bust our first myth today around sustainable forestry causes deforestation. Matt, over to you.
Thank you, Stephen. The very first myth I'm able to bust is that I'm actually based in New South Wales. I live just outside of Canberra, so that's the first myth busted. That's all good. Hopefully everyone can see my screen and everyone can hear me okay. So just to introduce myself just briefly, so I'm a forester by background, having studied forestry at the ANU, and I worked as an operational forester for about 11 years for Forestry Corporation of New South Wales. So managed both native and plantation forests. And I spent about six years working in forestry policy, so both for the Australian government and also the Australian Forest Products Association, or AFPA, and AFPA is the key forestry body representing the forest industry in Australia. So similar to the National Farmers Federation or the Minerals Council, for example. So I've been in this role with Responsible Wood now for about 18 months. So I'm just going to, my presentation is going to provide an overview of sustainable forest management and also the role that certification plays in combating deforestation. I like to show this slide initially because this slide clearly articulates what deforestation is. So deforestation is a land use change where a forest is cleared for another purpose. That's where forest certification comes into place. So forest certification was established in the 1990s as a means to halt or combat deforestation. So forest and wood-based products that carry a forest certification label confirm that forest and wood-based product originated from a forest that is still a forest, and the trees in that forest that were removed are regrowing and also regenerating. So the organisation that I work for is known as Responsible Wood. So Responsible Wood is the national governing body for PEFC, which is the program for the endorsement of forest certification, which is the world's largest forest certification scheme. So at Responsible Wood and PEFC, we have two standards. So one for sustainable forest management and one for chain of custody. So the top image, that's the top image just helps to describe the Sustainable Forest Management Standard. So the Sustainable Forest Management Standard, that applies to forest growers and forest managers. And those images on the top of that screen there, those are actually from forests within Australia. And this confirms that forest remains forest. So that, as I said before, trees that are removed are replanted and regenerate. And this is absolutely not deforestation. And those are all from forests within Australia. So those are all examples of forests that are certified under the Responsible Wood PFC scheme. And then chain of custody certification. So chain of custody certification basically tracks the forest and wood-based product all the way from the forest, all the way through the processing, manufacturing, retailing, wholesaling process. And that also confirms that the forest and wood-based products have not only come from a forest that remains a forest, but also confirm that it's followed a responsible supply chain process all the way through to the end consumer. So underpinning certification is the Montreal Process Criteria and Indicators, and these are internationally recognised reporting mechanism, which covers the environmental, economic and social aspects and management of forests. So not just forests that are available and suitable for forest production purposes, but also forests that are available and suitable for conservation purposes as well. Also underpinning forest certification are the United Nations Sustainable Development Goals. And these basically ensure that organisations provide a safe and healthy workplace, and also that forests provide for local communities and demonstrate a commitment to responsible practices and also minimise their carbon footprint. So forest certification is more than just a double checking to make sure that organisations are complying with regulation and associated legislations. Also ensures that forest managers and forest growers are abiding by the Montreal Process Criteria and Indicators, and also the United Nations Sustainable Development Goals. I just want to put this up quickly just to provide a brief overview of the different forest types, particularly in Australia. You might have heard terms hardwood and softwood used quite a bit. So in Australia, the term hardwood and softwood gets used quite a bit. Also the term native forest or natural forest. So in Australia, from our native forests, we have about 132 million hectares of native forests in Australia. And the vast majority of high quality hardwood timber is actually sourced from our native forests. When I say high quality hardwood timber, I'm talking about timber that's used for example, flooring and decking, and also engineered wood products as well. And hardwood plantations. So hardwood plantations are basically eucalypt plantations, and they generally grown on about 10 to 12 year rotations. And the vast majority of product that's derived from those plantations is used for high quality paper, for example. Sawlog material is also obtained from them, but it's primarily high quality paper used in photocopying and magazines and that type of thing. And softwood plantations. So softwood plantations are generally grown for about 30 years, and the vast majority of product derived from our softwood plantations in Australia is used for house frames, but also for packaging and paper as well. We have about 1.7 million hectares of plantations across Australia, which is pretty much evenly split between hardwood and softwood plantations. So it's not that well known, but Australia is actually the 6th or the 7th most forested country in the world. And as I said earlier, about 132 million hectares of native forest, and about 1.7 million hectares of plantation forest in Australia. So Australia's forests over 65,000 plus years have really adapted to some sort of human disturbance. So our traditional owners, it's quite well known that our traditional owners use fire as a friend, not as a foe. So what they did was they actually introduced fire into the forested landscape, and they would do that intentionally because they would intentionally clear sections of the forest. And by clearing sections of the forest, they would allow for grasses to grow where there once were trees, and that would encourage large animals like kangaroos to come in and graze in those areas. And it was actually known as one of the earliest forms of agriculture, known as fire stick farming. So for 65,000 plus years, our forests have adapted to some sort of human disturbance. And these days we have 25 million people scattered all across the country, so we can't just throw a match in the bush and let our forests burn. So that's where sustainable forest management comes into play, and goes a long way to replicate what our traditional owners did for 65,000 plus years. So that image on the left-hand side there, that's me in a forest with a traditional owner who's actually a forest manager And that forest in the background is actually a native or a natural forest that's been harvested several times. And as you can see, it's absolutely regrown and regenerated as well. So these are just some images from a typical native forest harvesting operation. So as you can see, it's a time sequence of photos. So the image one on the left, on the top left-hand side there, that's about 6 months after a forest harvesting operation has been undertaken. And as you can see, trees have been retained. So trees are retained by law under various codes of practice. The trees are retained for seed dispersal, also for habitat as well. And after a forest harvesting operation, generally, not all the time, but generally, a light burn is introduced. And what that light burn does, that actually reduces the fuel load on the forest floor and creates a mineral ash seed bed. And the smoke from that burn actually induces seed fall. So the eucalypt seed pods that are retained for seed dispersal actually open and disperse their seeds. And as you can see, images 2, 3, and 4 are all taken from the same location. The forest is actually regenerating quite well. Here's an aerial image just showing that's not the same forest. It's a different forest. It's also a native or a natural forest. And you can quite clearly see that area within the red circled area. That's you can see the trees have been retained and the forest is regrowing and regenerating. And all that surrounding forest has also been harvested previously as well. These are just some images to show some plantation images. So the top left-hand side there, that's actually the Blowering Dam Nursery in Tumut. And the one in the right-hand corner there, that's actually the Grafton Nursery. So the one on the left-hand side there, they actually grow millions and millions of pine seedlings a year. And the one on the bottom right-hand corner there, up at Grafton, they actually grow millions of hardwood or eucalypt seedlings as well. That image on the right-hand side there is actually a photo of me, unfortunately. That was actually taken at Invercargill last year. That's actually in front of a Eucalyptus nitens or shining gum plantation on the South Island of New Zealand. So you can quite clearly see the different trees that are regrowing and regenerating. Bottom left-hand side there is just an image of someone planting pine trees in a softwood plantation in South Australia. Just want to show this image quickly. This is actually of a harvest plan. This is a typical harvest plan that's used by forest managers and forest growers. This image just sort of shows that forest management is actually very highly regulated, and there are rules in place to ensure that deforestation doesn't occur. So this really demonstrates the planning that's undertaken prior to a harvesting operation. So just quickly on that map there, you can see the light yellow areas. Those are the areas that are available for harvesting. And all of the other areas with all the pretty colours, they're pretty much excluded from harvesting. So prior to any forest harvesting operation, surveys are undertaken for flora and fauna, and continual auditing is undertaken during and also after the harvesting operation. So it's not just a case of contractors turning up and looking into it. There's a lot of planning that goes into play before any forest harvesting operation. And the very last slide I want to share, we've actually held, if you're interested in learning more about forestry and sustainable forest management, we've just been rolling out a few field trips recently. So we actually held one yesterday up at Port Macquarie, and that was actually demonstrating sustainable forest management. So yeah, thank you, Stephen.
Thank you, Matt. Fantastic presentation there, and especially for me, the map around the forestry coding, how you sort of manage those forests. Look, I do have a question for you, mate, which is my single entitled myth-busting question. And that would be, you mentioned certification, which ensures deforestation does not occur within certified forests. What are some of the other benefits of certification, and why should consumers, designers purchase or select forest and wood-based products that are certified as opposed to uncertified products?
Yeah, that's a really good question, Stephen. So as I sort of mentioned in my presentation, certification is more than just a double check. So it's more than just a double check that organisations are complying with regulation and legislation. It also ensures that organisations are providing a safe and healthy workplace for their workers. So whether they're forest contractors, whether they're workers at a sawmill, for example, or a manufacturing or a processing facility. And it also ensures that forests are providing for local communities as well. And also demonstrates that organisations all the way along the supply chain have got a commitment to responsible practices, and also minimising their carbon footprint as well. So that's that goes over and above just checking for legal and regulatory compliance.
Yeah, no, fantastic. All right, Matt, thank you so much today for your material. Really compelling stuff.
Thanks, Stephen. Thank you.
You're welcome. I'd now like to introduce Mythbuster number 2, Tim Woods, Managing Director at Industry Edge, who will contemplate timber supply How does Australia ensure it has sufficient EWPs to meet expected demand growth? Over to you, Tim.
Thanks very much, Stephen, and thank you all. I'll just share my screen. I think that's working. To reframe this, first of all, as a myth, the myth would be that Australia does not have sufficient engineered wood products to meet expected demand growth. And I think we can demonstrate for you that that's not only is the case now, but it's going to be the case in the future. There's obviously a symbiotic relationship between demand on the one hand and supply on the other, and I'll explain where we're up to with that, because demand's definitely growing for engineered wood products, but so too is supply growth, and especially and importantly, local supply growth. So what are we going to address here, albeit briefly? We're going to address what are engineered wood products, what they might be and what they might not be, where they're used most predominantly currently. We can talk about local and import supply and the new and emerging local supply that can give us confidence that we'll have sufficient engineered wood products available to us long into the future. And a couple of examples in respect of that. I think the starting point with engineered wood products is to understand that the nature of the engineering means that the wood product has been reassembled. So it's been dismantled in some way. In some cases, it might be chipped and turned into wood panels like particle board or oriented strand board, or sawdust and other fines might be manufactured into medium density fibre boards. And of course, then there's peeled products like those you can see that are plywood and laminated veneer lumber on the top left-hand and middle left-hand sides. Those products are pretty similar to one another. And they involve peeling wood via a rotary peeling mechanism method, and then the reassembly of that wood in different layers and different thicknesses and even different species for different strength and utilisation characteristics, so that plywood might be used on a floor or on a wall, but the laminated veneer lumber purpose, of course, might be, as the graphic shows, used as posts and beams. And then there are a series of products that are made in factory. We think of them as factory-built engineered wood products, like I-joists and girder trusses that are beginning to predominate in the residential housing space, in particular in between the first and second floors of buildings, townhouses and houses. And those items in the bottom left, they can be manufactured in a whole range of settings. Some of them use pieces of solid wood, along with other engineered wood products, like the I-joist you can see there uses some laminated veneer lumber as well as some oriented strand board to make a joist that can be used really efficiently in the home building process. The good friends side by side in some ways, laminated veneer lumber and glue laminated timber. So glue laminated timber, unlike the peeled laminated veneer lumber, LVL, the glue lam is manufactured from pieces of timber that have already been cut. They're typically finger jointed together, and then they're layered together to make a post or a beam. The same applies often with the laminated veneer lumber, and we see increasing proportions of that material used in the Australian built environment, the global built environment also. And largely that's because they're very efficient products. In some cases, they're using offcuts. In the case of glue laminated timber, in some cases, they're using timber that would otherwise go to a lower value use, something outside of the built environment. And in other cases, they're maximising by rotary peeling a round log. You extract more usable material than you do just by cutting timber into lengths of typical structural timber. With laminated veneer lumber and glue lam, they're often used for post and beam functions. And of course, glue lam is used alongside its sibling, manufactured in a very similar way, the cross laminated timber, and those are the two really big elements in the mass timber market, and the mass timber that's often used to make multi-storey apartment buildings and is increasingly being used for that. You can see down the bottom there that housing dominates on that left-hand side, and the swing point, in my view, is between housing and commercial / industrial buildings, is where glue laminated timber can be used in either format, just depending on the size and scale and the particular look that might be being considered, and the sustainability outcomes that are seeking to be achieved. So these are pretty efficient building products, and they're able to be manufactured from product that otherwise might not make its way into the built environment. Their use is growing fairly substantially. And that's going to be really important for us, because the economic pointy heads, like myself, will appreciate one really key thing in our society is that we have a significantly growing population, and albeit there's been that little bubble through the trough, and now the big spike in population as a result of the pandemic, we're going to see significant population growth over the course of the next decade or more at least, but probably through the next 30 or 40 years, we'll see significant migration-fueled population growth. And the other thing that goes with that, we've got a growing population, but we've also got significantly declining average household sizes. And that's, a household that was once nearly 3 people per household is now down around 2.5 people per household. And every time we drop that, as we did in the pandemic, from say 2.5 to 2.4, we need 140,000 new dwellings. And interestingly, every time we drop that, on average, we need smaller dwellings, because we no longer need the 7-bedroom house. We don't need the 4-bedroom house either, but we don't need the 7-bedroom house anymore. We need a smaller house, because increasingly this cohort of 2.5 people per, less than 2.5 people per household, means that we also have a very large number of single-person households, mainly older people, retirees, but not only those. So we're going to have more and smaller dwellings, and we're going to manufacture them in different ways. And there's a really key reason we're going to manufacture them in different ways. It's because, in large extent, our traditional process of building houses is broken. It's no longer fit for purpose. And one of the features of it no longer being fit for purpose is that we often lay out a concrete slab somewhere in our housing market. We build some factory elements like timber frames and trusses. We deliver them to site, and then we take something like 10 months to finish the house. So on average now it's taking close to 10 months to finish a house that used to take 6 months to build. There's a whole lot of pre-dependent trades and interactions that are destructive of value, but they're also destructive of time and materials. There's more waste comes off housing construction sites than any of us could possibly tolerate. So we think that if we're going to have to provide significantly more houses for significantly more people in smaller households, we're going to have to build much more efficiently. That revolution is probably on our doorstep right now, and it involves forms of prefabrication, and engineered wood products are a key part of that form of prefabrication. It is absolutely no error and no accident that the introduction of frames and trusses being prefabricated into the Australian and in fact the global housing economy came about more or less at the same time as there was big growth in the use of engineered wood products. Engineered wood products built in a factory, used in a factory. But ever since the Industrial Revolution began, we've used factories because they're a more efficient way to do our building. And that's what we're dealing with right now with engineered wood products. Typically, we would have expected about 60% of our engineered wood products to be imported. The import proportion is declining, but it's declining for 2 reasons. One is because consumption has declined, but also because, as you can see here, production of locally produced engineered wood products is increasing. So we've always had sufficient engineered wood products, but more and more of it now is being domestically produced. We've got a 60% reliance on imported product currently. And it's really relevant for those in mass timber. Thanks to the work of XLAM, Next Timber and CUSP, among others, we're now self-sufficient for CLT and glulam. Post and beam products in LVL and GLT. The new Next Timber product by Timberlink adds GLT capacity for those in the housing market as well as in the mass timber market. And there's some pretty exciting recovery of fabricator waste being used to produce GLT post-production, where previously that would have been going to biomass or even to landfill. And flooring systems can continue to be built in many different types of factories. Really important things to note too, Matt talked before about plantation hardwoods being used for pulp and paper. There's engineered wood product trials underway in the Green Triangle region, South Australia, Victoria, to produce glue laminated timber and laminated veneer lumber from plantation hardwoods along with plantation softwoods. Instead of exporting wood chips, we might find ourselves at some point exporting engineered wood products, but certainly making more of them locally. So the sum up really is this, that engineered wood products are efficient, they're highly flexible, they're very useful in factories. Supply was actually consistent during the pandemic, just delayed by shipping. Import reliance is, however, declining because resource efficiency is increasing via domestic production methodologies and expansions. And there's quite a bit of research underway in respect of that. That allows me with some confidence to say that Australia can expect to have sufficient engineered wood product supply long into the future. Thanks very much, Steve.
Thank you, Tim. Fantastic presentation, and I think it's really important that everybody in the industry online here understands that Australia's industry is really sort of making headway in terms of our supply and our various product availabilities. But just my question quickly, I'm not sure if you touched on all of this, but rumour has it that Australia received a great volume of its laminated veneer lumber from Russia until, well, recently. Where is it coming from now, and how secure is that import supply?
Yeah, I think that's important, Stephen. True. Significant amount of LVL came directly from Russia prior to its illegal war on the Ukraine. Almost immediately, the supply chain switched to supply from Turkey, some from Southeast Asia, some from China. There is a question, and this goes to the question of certification and reliability. There is a question about some of the Chinese material and whether it involves logs that might have come from Russia. How do you find out? You check with certification bodies like Responsible Wood, and you do provenance testing. We've also received significant amounts of additional supply from North America, which comes and goes from our market depending on how strong their housing market is. So there's always been supply available, and there's always been that swing capacity available, notwithstanding a pretty significant volume that was coming out of Russia for a while.
Okay, great. No, really good to know. So if anyone's got any questions around source, get in touch with our suppliers and our experts today. Thanks again, Tim. Our third mythbuster is someone probably well known in the industry. I'd like to introduce Carl Heinz Weiss, Director at Weiss Insights, who will today bust why timber buildings are a fire risk and can't be insured. Carl?
Thanks, Stephen. Thanks for having me. The title and that myth is a hard one to bust, right? And let me just share my screen. Here we are. So it's a hard one to bust because obviously we look in timber buildings are a fire risk. We all understand actually, and we all have been experiencing that, sitting in front of a nice fire and timber fire, and it warms, so timber burns. And the second part to that, can timber buildings be insured? There are actually two kind of slightly separate aspects in that myth, which we gonna try to unpack in the coming slides. Firstly, kind of blank confirmation. Yes, timber buildings can be insured. And I can say this confidently because I've been involved over the last 18 years in over 100 buildings in Europe and in Australia, and they can be insured. I start just with one, kind of highlight one very briefly. It's Stadthaus Margrove, built in 2008. So it's about 15 years ago, more or less on the day, 15 years ago, people start moving into this building. And interestingly enough, once we have got a bit more time towards the end or in the conversation, there has been a fire in that building, actually post-occupancy. The other part of my experience is more Australia related. You might see some of the buildings here, like Library at Dock, 25 King Street, International House, Darramul House, and last but not least, the Forte building. And the Forte building was actually Australia's first mass timber building at scale, a residential building just over 30.26 meters in height, 10 floors overall. And nobody has done it before. Nobody has done 32 meters. Obviously, Stadthaus Murray Grove was just under 30 meters, but nobody has been doing 32 meters in this country. So how can you get a building like this insured? And again, there's kind of a lengthy story to be shared, but the CBA head of risk, as CBA as one of the mortgage providers, really try to get a good understanding of how actually the system works. What's the product? How is it manufactured? How is it being assembled? And I spent an entire week with him traveling in the UK and showing him around. So that's probably describes a bit of the journey everybody is going through. So if we look into moving from the insurance perspective, a little bit more to the risk perspective, and I confirm that kind of myth to a certain extent. Say yes, there are risks, and one of the most significant fires we had in buildings. However, I have to be very clear: this is not a timber building. But I think fire and fire risk is not exclusive to timber buildings. It actually shows there is a real kind of deep consideration which needs to be taken into account during the whole project life cycle. So 2017, the Grenfell Tower burned for over 60 hours and 74 people died. And the property damage, which obviously in relation to 74 people dying is not that relevant, but it's relevant from an insurance perspective. It's still an estimated figure between 200 million British pounds and 1 billion British pounds. And we'll come to that in a second. So what makes actually a fire? I think that's an important understanding I want to share with you just at a very high level. We can talk for hours on this topic. But actually fire in a building, and this is regardless of the structure, regardless of the material, regardless of the use of the building, a fire always requires 3 key ingredients. It's an energy source, it needs combustible material, and it needs actually oxygen supply. And in the case of timber, so just to describe, this is the cause of fire. And in the case of a timber structure, it's a slightly different story. So the fire doesn't start with the timber structure. The fire responds to, the timber responds to the fire. So you've got an increased temperature, you've got a fire load in the building. And actually most of the fires, over 40% in New South Wales, are actually triggered by electrical faults. In kind of, cooking is one of the issues, ironing boards, etc. So about 40%, the root cause goes back to electrical faults in equipment. So timber responds to the fire, and the immediate kind of reaction is actually let's encapsulate the timber or calculate with a charring rate. And obviously you see that image in the background. Charring means the timber starts to char, and the char layer kind of creates a layer of protection and insulation of the core timber, the structural material. The other aspect, which is addressing actually the fire directly, is suppression sprinklers. And I think this is, in the meantime, became really good practice to have, especially apartment buildings taller than 3 floors, fully equipped with sprinklers. And the other part of really good practice is actually engage fire engineer. and engage with key stakeholders. And my experience shows actually talking to brigade, talking to insurers and other key stakeholders early pays off, because everybody will participate on that journey. And that kind of engagement actually starts building competency. Competency across the whole value chain is actually required. And if we go back for a second on the Grenfell Tower fire catastrophe, it shows actually across the whole value chain and decision-making chain, incompetency has led to that catastrophic outcome. Again, it's not driven by materials, it's by incompetent decision-making throughout. And insurers start understanding that. So typical approach to actually create certainty around product performance is you look into code, you execute testing, and timber has been burned across the globe to a significant amount to really gather data, and data is available. However, most of the testing is kind of referring to the EN 13823, and what's SBI is a single burning item test. So you look into a product in isolation, you build little corners of a room, and you test a product, which is not really kind of a direct life scenario. The other part of certainty we create, and I see Stephen popping up, so I'm running slightly over time, so I speed up now. Is looking into charring, so the char layer around the core structural element, protecting its structural integrity. However, it's not only about fire, and if we look at the insurance aspects, there are again three levels: is smoke, fire, and actually one of the big concerns is actually water and water ingress, even during fire or firefighting. So what is kind of the insurance role? The insurance looks at the physical asset, the building, and actually looks into the asset performance, the asset delivery in the construction, and asset operations / occupation. So that's the insurance focus. And the insurance customer is the owner, the investor, the mortgage lender. They want to ensure actually the asset they insuring has got the right value and doesn't lose in value. And that means it's the focus on damage or loss of property. And they look as well into potential risk of business interruption. But in summary, it's kind of 6 aspects insurers look into: occupancy, scale of building. Occupancy means how is the building used, structure and fabric, and there again, timber is one element of that. Other risk factors like landscaping, balconies, etc. And then insurers will look into your fire mitigation strategy and water exposure mitigation strategy. That's an important part. And once you work through these details, actually insurers are on board and happy to provide insurance. In another kind of context, obviously life safety is governed by legislation, and insurers looks into kind of fire, flood, escape of water, security aspects of the building, call it building or property resilience, just really from a strong focus on the asset. There is and that graph has been taken out of an interesting resource. It's the Mass Timber Insurance Playbook. Has been put together in the UK, kind of in collaboration with insurance companies. It's worthwhile. It's free to download. So keep that in mind and work through, because it's very detailed in all the risk aspects. And again, just in a summary, building competency is a continuous journey. As we all go through, if we go to driving through a driving license process, we have to build a competency, and then insurers will drop their premiums once you kind of successfully have been trained. And last but not least, fail fast, learn fast is a word we hear so often. It is not an option for the built environment because we're dealing with a safety of life. That's me.
Thank you, Carl. I think perhaps in this country we're still on our learner plates at the moment. That's really interesting because I guess, and just from my involvement with MECLA over the last year, it's been really interesting to understand across parts of the industry who does and who doesn't have a lot of knowledge and experience around this, which informs, you know, those solutions to help break down the barriers. I guess at the heart of what you're saying today, it's about education and educating the insurance industry around this. I mean, my simple question for you on this myth was going to be, so do we need to clad the beautiful timber, you know, in fire check or fire rated chip in order for it to be an acceptable solution? Or do we just over design the char in the timber members? Does that help us get there? But it seems to be much more complex.
It is much more complex. Obviously, the tendency to encapsulate is kind of, you know, attractive in a way. At the same time, you lose the attraction of the timber. And as you maybe have spotted, and even that background image right now, it shows lots of exposed timber. Many of the buildings I have been involved with have been showing off the timber because we want to kind of get that aspect of that biophilic design quality as well. It's a combination of really thorough fire engineering, the conversations with all the key stakeholders, and in this case, it's not only the insurers, it's a brigade. Right?
Yeah, brigade. Yep.
And you want to, and you look into what's your escape strategy. How can you get people out of the building quickly, etc., etc.? What's the height? How far do you want to push? And we see now, even in the international building code, the IPC in the US, there is a move away from 100% encapsulation, increasing actually the areas where you can leave timber exposed, even in taller structures, because more and more work has been done in the background, more and more testing has been done.
Right.
And the good thing, the testing has been shared.
Yeah. Thank you, Carl, once again. Always a pleasure.
That was.
Just before we go to our last Mythbuster, I'd just like to let everybody online know that we do have a poll, which we'll release at this moment. We've got 2 multiple choice and 2 field answers for you to duly populate at will. We'd love to hear back from you, and that just helps us get an idea of who in the industry is attending, but also a level of knowledge. My next speaker will be Steve Mitchell, Director at ThinkStep, and Steve will pose the myth around carbon stored in wood products is always emitted at end of life. Steve, over to you.
Thank you, Stephen. And thanks everybody for having me here today. So yeah, my myth, I'm looking at the other end of the supply chain, the end of life, after the building is come to its final use. Just a little bit about ThinkStep. We're a team of about 50 professionals, sustainability professionals across Australia and New Zealand. There's our great team meeting in Wellington earlier this year. We've got 15 years of experience in a range of sustainability work, including strategy, reporting, communication software, product design, as well as carbon strategy. So we've got lots of large, medium and small clients working on sometimes on integrated strategies for sustainability. So just a basic concept, which many of you would be familiar with, but 50% of the dry weight of wood is carbon. Carbon compounds make up most of the wood, and when it comes to a molecular level, 50% of the dry weight of wood is carbon. So we have to know our carbon story really well. And at end of life, there are different implications of where that carbon goes. I'll briefly touch on these three items, recycling and bioenergy, and focus my main presentation on the landfill, but I wanted to briefly touch on these other management options for timber at end of life as well. So recycling, reuse, reclamation, salvage, a lot of the design community and people are very familiar with this idea of taking timber from old bridges, old buildings, old telegraph poles in this example here, and converting that, reusing it as it is, or cutting it and reusing it into another form, such as is beautifully done on the right-hand side of these pictures. Plenty of reclamation salvage companies around Australia where you can find this timber. Now, recycling, you're turning the product, the end-of-life timber, into a new product, and increasingly what's happening with a lot of end-of-life timber is new particle board is being made. A fantastic example out at Oberon, New South Wales, which, by the way, has the largest industrial solar panel production on its roof in Australia. They convert a lot of end-of-life wood into new particle board. What also happens is that low quality wood, end-of-life wood, finds its way into mulches, potting mix, and animal bedding. Obviously, the carbon of these gets extended into this new life of these products. Now, bioenergy is also increasingly happening in Australia. End-of-life timber is substituting for coal in cement making. And that includes at a facility south of Sydney at Berrima, run by Boral Cement, as well as Birkenhead near Port Adelaide in South Australia by Adbury. So this end-of-life timber is helping reduce their fossil fuel embodied carbon content of their products. Now, obviously, the carbon in this application is completely released back into the atmosphere. Now, what happens to the end-of-life wood when it's disposed to landfill in Australia? Well, at the moment, about 59% of all end-of-life wood ends up in landfill. This has actually decreased quite a lot in the last 10 years due to those other options for end-of-life wood becoming more economic. So I think even 10 years ago, it was probably more like 80% were disposed to landfill. Now it's like 59 and reducing. But still a lot of it, the majority of it goes to landfill. But what happens? Well, fortunately, we have a very good research scientist who's been digging up landfills to see what's happened over the last 50 to 100 years for wood and paper products in landfill. Fabiano Ximenez, he's a senior research scientist with New South Wales Department of Primary Industry. I met him about 12 years ago at Meadowbank. He's digging up an old football field, which used to be a landfill. Here's a couple of photos from the landfills that he and his team have dug up in Brisbane and on the right-hand side at Lucas Heights. There's Fabiano and his team smiling on the pile of muck there. And there's the types of timbers and products that they're pulling out. You see the MDF on the right-hand side, solid wood products down the bottom there. And the photo down the left-hand side is the good news for Fabiano and his team is they don't dig up landfills anymore. They use an artificial landfill in a lab-based environment now to do their research. Okay, but what did they find digging up this wood products? Well, they found some old newspapers, memories of Paul Keating and meeting the Queen. So they can compare those ones that they dug up, the one on the bottom with the one in the library, the one at the top. So they can actually date what samples and products they're pulling out of landfill. Similarly with novels, popular A-Team novel there. So here's some samples of wood that spent 46 years in landfill. Now, as it's pretty obvious, you can actually, that's been cleaned up of its mud and whatever, but you can actually see that there's been very little degradation of the wood in the landfill. The environment is not conducive for degradation. And so they're consistently finding this in every research project that they've undertaken, that the very little degradation and decomposition of that carbon in the wood resulting in any emissions, in very low emissions to the environment. Now, I'm not going to, in the time available, go through this data in specific detail. There is some variation between species, and the operation of a landfill is not just about how much, how it degrades, but also that some of that very small volume of degradation that does happen, it is absorbed by the landfill, the soil that covers the landfill. In some landfills, any methane is, for example, generated is also burnt off. But on the whole, the studies are showing that a maximum of 1.4% of the carbon in end-of-life wood products is lost from Australian landfills. There are other researchers in the United States researching this topic, because landfill is a top popular waste management option in the United States and in New Zealand, and they're consistently finding the same results for all wood products. Interestingly, you'll see bamboo flooring down there that actually, which is a grass-based product, they're finding that the carbon loss from those sort of products is significantly higher. But overall, maximum of 1.4% of carbon lost in end-of-life wood buried in landfills. Now, this research is actually finding its way into IPCC, International Panel Investigating Climate Change, included in the Global Emissions Database. So finding its way into the peer-reviewed research and into the IPCC databases. Again, I'm not going to go into the detail of this particular graph, but these factors for wood products and their degradation landfill have come down a lot over the years, and they started off very, very high, which might be a source for that myth, because there was a very, very conservative view taken back in 2006. But as the research has developed, the numbers keep coming down further and further until with this study and these studies of Fabiano and his team, you get down to the 1.4%. Just briefly, how do we use that information in building and construction? Well, anyone familiar with EPDs is familiar with A1 to A3, the production stage, and how you account for carbon emissions during production. Well, C4 is where you account for the end of life stage and the emissions at the end of life stage. So with the development of EN 15804 EPD core rules for construction products, we actually include the values for degradation in landfills in the C4 module. In the latest versions of EN 15804, we have to include this information in the other environmental information section of the EPD. If anyone's got any questions about that, happy to answer them. But here's a grab from the Timberlink EPD, where that very low degradation number is included in the other environmental information section. So if you are incorporating end of life in your life cycle assessments of your buildings or your structures, that's where you can look for the information in the latest versions of the EPDs. Another advertisement, we've actually working with Forest and Wood Products Australia on the carbon story, and basing it all on very good peer-reviewed research. And so these three guides are two of them are already available, and the central one, which is more appropriate for architects and designers attending this presentation, that should be out any day now. Okay, I was hoping to have it out today, but that should be out very soon through the Wood Solutions portal. So thank you very much. I'm happy to answer some questions, Stephen.
Thank you, Steve. Again, really insightful in another compelling area at the end of life. It's interesting. I think about timber, in my home environment as well, where there's timber sort of close to the ground or in touch with the ground, and how over the years it does degrade and it goes off and it splits, and then there's dry rot, etc. But the question I've got around your content today is, why doesn't the carbon in timber degrade much when it is landfilled?
Yep, very good question, Stephen. And the answer is, as the Venetians found when they were building Venice, is when you put timber in an environment where there's either there's no oxygen, the fungus that actually degrade the wood, because bacteria doesn't degrade wood to any large degree. It's the fungus that degrades wood. It took about $60 million years for that fungus to evolve, by the way. But the fungus that degrades wood cannot survive in a landfill. It's either no oxygen, it's too wet, or it's too dry, or two of those elements are enough for it to, or one of those elements is enough for it not to degrade. And usually in a landfill, you'd have two of those elements.
Great.
So no oxygen.
No oxygen. I kind of thought that might be the answer. Look, and Steve, thanks very much. And hold your horses right there, because the next part of this myth busting session today, everyone, is the panel discussion. And I'd like to hand over now to Alistair Woodard from Wood Solutions. And have all the speakers online, please, with your cameras on. And we've got a healthy bunch of questions building as well on the Q&A, Alistair. But look, I'll hand it over to you, Alistair, and the team, and let's crack on.
Thanks, Stephen. And you're right. And in addition to the questions we've got online, we've also had some questions sort of posted to the group earlier, which we'll get through as many as we can as well. Look, a question that has come up quite regularly here through a number of the different questions, particularly to certification, if I can just pass this one on to Matt, is the mention about also about Forest Stewardship Council, which wasn't mentioned, Matt. So I know you represent Responsible Wood, but clearly there are more than one certification scheme out. Would you like to just to chat a little bit more about both of them and how sort of they're similar or how they differ? Because I think that's really important for people to be quite clear on the different certification schemes that exist.
Yeah, thanks, Alistair. Just to qualify too, normally when I give presentations, I do mention both schemes, but I had a pretty limited time frame of 10 minutes. I think I went way over anyway, so didn't quite get a chance to give my spiel. So thank you very much for that question. So look, both schemes were established in the 1990s. So FSC, the Forest Stewardship Council, was established in about 1995. And then in about 1999, PFC, the Program for the Endorsement of Forest Certification, was established, and both schemes were established pretty much for the same purpose, to halt or combat deforestation. So fundamentally, both schemes are very similar. Both schemes have a sustainable forest management and a chain of custody standard, as I described briefly. As far as the size of both schemes, so for example, PFC has just under 300 million hectares of forest certified globally. FSC has about 160 million hectares of forest certified globally. Probably one of the major sort of fundamental differences between the two schemes is that PFC has what I would describe as a bottom-up approach. So when I say a bottom-up approach, our standards for both sustainable forest management and chain of custody certification for the national governing bodies, such as Responsible Wood, which is the national governing body for PFC in Australia and New Zealand, are largely tailor-made for Australian and New Zealand operating conditions, whereas FSC has more of a top-down approach. They have the one global international standard that's applied globally. They do have a standard for Australia and New Zealand, but it is largely based on the international version. So look, I suppose in summary, Alistair, both schemes were established for the same reason. So if you purchase products that have got either the FSC or the PFC Responsible Wood label on it, you can be assured that it's come from a sustainably managed forest, and that forest is still a forest, so deforestation hasn't taken place.
Thanks, Matt. Yeah, no, it's really important, and the industry certainly encourages people to be asking for certified wood. I mean, Stephen asked earlier on about, Matt, what's the benefit of certified wood, and one of the big benefits is that a lot of the wood that's imported and used around the world is illegal timber, and I think it's something like 14% of the wood that eventually ends in Australia comes from illegal sources as well, and that's the last thing we want to be doing. So wherever we can, we want to ensure that that there's proper, credible sort of tracking of where that wood comes from. Karl-Heinz, we had a question in the sort of pre-questions. You were discussing in your sort of presentation around fire resistance. But people are also keen to understand the potential for termite damage and how you deal with that with wood, which is a good question.
Yeah, I should have referred to it because one of the background images was actually the termite pavilion, which we exhibited back in London in front of the Royal Albert Hall for many months. Yeah, obviously termite and fire are kind of can't be further apart from each other, and at the same time similar principles apply. And it's kind of, you know, if you deal with fire safety, you want to be thorough. If you deal with termite and insect attack, you want to be thorough. You want to understand actually the root cause. You want to understand not only how a fire occurs, you want to understand the conditions where actually termites will flourish. And again, they will require certain conditions. And we heard this from Steve earlier as well. Certain conditions in terms of termites, it's dark, humid, no flow of air. That's actually an environment where termites can really expand their colonies, and they will kind of eat into timber. The same with kind of been referring to that in the past. You want to put a timber building on kind of strong shoes, strong boots, so you're going to stay away from the ground. You want to have kind of, you know, inspection points, etc. And all the engineered timber buildings delivered here in Australia are following these kind of, you know, really standard principles.
Thanks, Karl-Heinz. A question we also got just in the pre-ones, which I think is one that does come up quite regularly, and Tim, I'm not sure if you're able to answer this one, or Karl-Heinz, around the comparative cost of timber buildings compared to traditional construction and other forms of prefab.
Yeah, so without disclosing the builder, we've done some pretty extensive work with one of the largest builders in the country, who builds some houses in both timber and steel. And timber is cheaper as an end-to-end installed solution for a variety of reasons, including that it's lighter weight, it's more easily managed and adjusted on the job if it needs to be. It transports more, generally speaking, transports more easily and is somewhat more forgiving overall. But in terms of cost, it depends how much you do in timber. The more of it that you do in timber, the more the advantage gets. But even if you just put up, say, a single wall in timber versus a timber wall in steel, the advantage is the timber has a cost advantage in general. But that gets better when you, say, want to transport 20 timber walls to a site to install, because you might only be able to put 10 to 12, say, steel walls and other steel items on the back of the same truck. And there's a range of extensions on that, right? You just keep going and going as you add more.
Did you want to add anything, Karl-Heinz?
Oh yeah, I can add a lot, because obviously Stephen and I had lengthy conversations around costing, and it's again, it needs to be unpacked. Right? So if we talk about it's more expensive or less expensive, we always have to understand it. Kind of, you know, bigger structures, the portion of the timber superstructure that does matter if it's an office building or a residential building. That cost portion is circa 15%. Goes a little bit up and down. This is the cost for a superstructure. Actually, the building envelope and building services are far higher. We talk about 20%, 25% for the building envelope and for the services. So it's kind of requires to understand actually are there any dependencies? Is the envelope different in a timber structure than actually in a traditional concrete structure? Is the services any different? So because we see typically slightly premium in the bigger timber-based developments. My experience out of the UK, having been there for 7-8 years, all the buildings we have been delivering over there, they needed to kind of stand up cost-wise. Otherwise, they wouldn't have built in timber. They wouldn't have used timber. So there's a pathway, but it needs to really, everybody needs to understand the dependencies here. Timber provides you a great opportunity to take a productized and industrialized approach to building, but it means you have to schedule your facade differently, your services differently, all your trades. Then you get to a real time saving, which can offset some of the slightly higher material costs.
Thanks, Bill. Heinz, I've just sort of clicked on the most upvotes just to rearrange some of these, and I've noticed there's quite a few questions here or concerns about from a group of people around harvesting down in Tasmania, by the sound of it, with native forest harvesting, which obviously we'll need to address here. I don't know, Matt, if you want to make some comment about native forest harvesting in Tasmania.
Can I just add to that as well, and sort of refer it, I guess, around also old growth stock and old growth forests, you know, because some of these queries do pertain to that, as well as the natural habitat, endangered species. How do we sort of manage that, and how do specifiers and architects understand when they are selecting a product what that source is?
Yeah, that's fine. That's a really good question. Thanks, Stephen and Alistair. So I suppose first of all, just to emphasise that, as I said earlier, Responsible Wood, we write and develop standards. So we're a standards development organisation, and we're licensed by Standards Australia to write and develop those standards. So the certification process. So, for example, certification of organisations such as Sustainable Timber Tasmania, that's done by third-party independent certification bodies or auditors. So Responsible Wood, we are quite rightly completely independent of that auditing process and that certification process. So independent certification bodies carry out that certification and that annual surveillance auditing, and then those auditors are also accredited by a national accreditation organisation. So in the case of Australia, we have JASANS, which is a joint Australia-New Zealand accreditation body, and they're also accredited by the International Accreditation Forum as well. So from responsible woods perspective, I'm not really sure of the exact ins and outs of the codes of practice. There's a few comments in there about the diameters of trees and that type of thing, but absolutely, as part of the Sustainable Forest Management Standard, for example, I mentioned when I spoke about the Montreal Process Criteria and Indicators, which are the internationally recognised criteria and indicators for sustainable forest management, which ensure that the economic, social and environmental aspects of forests and the management of forests are adhered to, whether they be reduction forests or conservation forests. And that includes ensuring that biodiversity values are protected, maintained, and also enhanced. So I suppose, Stephen, just going to your question there, the end users, for example, so architects, builders, designers, and specifiers with end users of forest and wood-based products. If you buy a product that's certified, so either to FSC or PFC responsible wood, you can be assured it's come from a forest that biodiversity values and cultural heritage values have been maintained and also protected. So it's more than just a double check. So the auditor goes out there and they confirm that the forest manager has complied with the local legislation, regulations, forestry codes of practice, and that type of thing, which also ensures that endangered species are protected. So, for example, at the Commonwealth level, there's the EPBC Act, Environment Protection and Biodiversity Conservation Act, but each state also has its own biodiversity legislation as well. So I can't emphasise enough how highly regulated forestry is within Australia. And as a forester myself, so someone who manage both native and plantation forests, particularly in New South Wales, and I've travelled the world a bit, and Australia has one of the most highly regulated and legislated forest management practices and guidelines anywhere in the world.
Thanks, Matt.
Thanks, Matt.
I might just add one, Alistair, if you don't mind.
Yeah, sure.
Just for the team, it might be for Steve. Question here, Steve, what are the end-of-life options for engineered wood products, particularly those with composite materials, including the glues?
Yeah, I saw that question come up. Well, I think we can be guided by what's been happening to end-of-life timber in the past, because a lot of these engineered wood products are pretty new to the market, like CLT and large dimension glue laminated timbers. And those glue laminated timbers in particular substitute for those big hardwood members that you can't get anymore.
Yeah.
We used to be really good about building those big wool stores and those big buildings with those big hardwood members.
Mm-hmm.
We're just relearning that, and what happens when those big timbers came out of those buildings is people grabbed them, reused them, repurposed them. And I'm personally of the view that, and that this is what's going to happen with these large dimension pieces of wood, because they're going to be exy, aren't they? They're not going to be cheap.
Yep.
So people are going to find a way to repurpose them, salvage them out of those buildings. And the fact that they're glued together is neither going to be here or there, because those glues are being tested widely for durability in those given structures. So I've got no qualms to sort of say that they're going to get reused in a large degree. And if they can't get reused, that being softwood products, they're much easier to recycle into that particle board and those composite wood products that we're finding now at taking those small dimension offcuts and pallet woods and all those low value, I'd call them low value wood, waste woods. The glues aren't a barrier to that. In fact, the fact that these are dry and clean and softwood actually makes them better to use as those composite wood products because of those attributes.
Thanks, Steve.
And thanks, Stephen. You jumped in. That was going to be the question I was actually going to ask about what happens at end of life with the glues. I mean, in reality, also, as Stephen mentioned, you know, the proportion of glue to wood is very small. So, you know, in terms of affecting environmental properties of the wood at end of life, it has a sort of fairly minimal effect. And actually chatting to some of the glue lamp producers, they're saying, you know, in 50, 100 years' time, when these bits of wood come out, they'd love to get hold of them again, even sort of routing out the glue lines and reusing the products or whatever. So at that end of life, I don't see that as being too big an issue. We've had some questions about with end of life. I mean, it's important when we have this discussion, even though MECLA is about embodied carbon, it is a full life cycle approach we need to be looking at, and that sort of, you know, and particularly that circular economy at end of life. And Steve, I know you've got a lot of experience here about yeah, how much wood goes to waste. It is something we really need to improve upon in Australia. Do you want to give your thoughts around that and how we improve upon it?
How we improve that recovery you're talking about?
Yeah, so we, you know, really we shouldn't be sort of using wood for waste at the end. We should be getting all of those outcomes out of it. Yeah,
well, there's a bit of a hierarchy in my view of, you got those high value woods I just talked about, then you've got those sort of middle value woods that are clean, but some woods should still go to landfill. I mean, we used to paint timber and all sorts of products with lead-based paints. We used to use fibro to build houses. That's just got asbestos. So really that stuff used to treat very dangerous termiticides. We used to spray around houses. All that stuff should still go to landfill. That's really the best place for it, in the ground. And, you know, it's reassuring to me that that carbon just sits there for the long term, provided the conditions don't change, no one goes digging it up and disturbing it. That just sits there, and in 60 million years' time, it's going to turn into coal, right? That's what's going to happen. Now, it's really interesting that companies like Australian Wood Panels and D&R Henderson are getting into this waste wood as a resource, okay? Because they were using virgin wood, and now they're reusing sort of end-of-life wood. There's actually an end-of-life wood shortage for these companies. They're actually, you know, searching for this type of material in the waste stream, because there is some really good uses for it. So I think the wood sector is really good at finding multiple uses for all different types of woods, whether that be you know, the wood chip, the solid wood, the bark, all that sort of elements. We're actually finding that's being reintroduced at the other end of the supply chain in the end of life wood cycle. I think Tim wanted to say something there, didn't you?
Maybe about before it becomes end of life. I think there's we know that shipping a pack of timber to a building site of any type will result in more waste than if we use the timber in a factory more efficiently. We'll end up with less waste. So you know, it's just part of the move toward prefabrication, is because it's a more efficient means of production. And so the more of that we do, the less production system, you know, building construction system waste we end up with, leave aside what we might do with the the end of life products, as Steve was just describing.
Yeah, and adding to that,
Good point.
it's about all the transport required when you're having things in remote locations as opposed to in a single factory. You know, the embodied carbon through logistics, etc. Can I just ask another one, guys? On the pre-registration stuff, this is around Green Star and ISC to ensure that the calculators reflect the latest embodied carbon or environmental impacts in using timber. I'm not sure if Green Star, I know that we've been involved, some of us, with the neighbours tool that's being created. Does anyone have an update on where that's at for the folk online? No?
Well, I mean, I can speak to that one if others can't, but Steve, you can probably speak to it from a think step perspective. So the timber industry is certainly working very closely with all of the groups, particularly neighbours, which is driving a lot of the embodied sort of carbon, I suppose, positions at the moment, and Green Star, which is obviously working very closely with neighbours. And certainly there's been a lot of work, I think, as people on the line here, if they've been close to MECLA, would know about sort of coming up with a sort of consistent approach to embodied emission numbers, which I think Neighbours has now agreed through its hierarchy is a process-based LCA approach using EPDs. Certainly the timber industry was one of the leaders initially in sort of investing in its life cycle data and has a range of environmental product declarations that are out there at the moment. And then Steve ThinkStep, I think, is advising to Neighbours at the moment who are putting together a database of sort of appropriate emission values over all the different building product sectors, aren't they? Which the timber industry is obviously involved with, and in providing that data as well.
Mm.
Yeah, that's right. The Neighbours methodology is going to be quite important in Australia to understand how you account for carbon, the CO2 that's sequestered by the wood when it's growing. You know, I've been talking about end of life and what happens, but really at the beginning, the CO2 is absorbed by the tree and it grows when it's growing, and that's an inherent property of the wood. So that is, you know, we always talk about that negative number as carbon storage, with the proviso that the wood has been sourced from a sustainably managed forest, and that's why things like PFC responsible wood and FSC certification is so important as ways of showing that your wood is being sustainably sourced, because there are unsustainable sources of wood out there. You know, there are land clearing operations or clearing for farms or urban development that are unsustainable sources of wood. So it's important to source sustainably wood so that CO2 that's absorbed by the wood is being replaced. That tree is being replaced when it's harvested, and then that tree that is grown replaces that wood. So I think it's a bit of education of people of how that sort of cycle works, and then incorporating that into key measures like Neighbours and Green Star, and getting people familiar with that, because we've been talking about carbon probably only the last 10 years. So as Carl's, I really like Carl's L plate, P plate analogy at the end of your presentation, Carl. It's the same space in this carbon space. People are probably at the red P stage, I think.
Hey, just a quick one for Tim, another Q&A. Tim, what role does bamboo have in manufactured housing?
Well, extensive. If you think about housing being where people live, then all throughout tropical and semi-tropical regions of the world, vast numbers of people live in bamboo-based housing. It's where you can grow it effectively and in the right sizes and so on. It's a fabulous product, and it has utility even more broadly than that. Whether it has application in more temperate environments is a forester's question, not a sort of an economist question. But yeah, it's a hugely used product, and increasingly in paper and paper products too.
Yeah,
thank you.
And overall fiber, you find bamboo fibers, even in clothing and bedding, etc., etc. So it's very similar to eucalyptus. You find eucalyptus fiber in shoes and fabrics, which is quite interesting. I see obviously bamboo having an impact from a flooring perspective already. You get engineered timber floors with bamboo finishes. There are certain initiatives in this country to try to encourage growers to grow bamboo and find a pathway. So certainly a space to watch.
Alistair, any more from yourself? But I've got one more.
Yeah, no, please, Steve.
Again, just from the registration set. For anybody here, please. Should we be taking carbon lost in harvest residue and carbon lost in withering rootstock of dead tree into account in our EPDs? What's the feel?
Steve, is that one to you?
The short answer to that question is the soil carbon science isn't settled. It's really a confusing picture. And when we start talking about taking stumps out of the ground and reducing your soil carbon, I just know in EPDs we assume, in the life cycle assessment we use for LPDs, we assume the soil carbon is not changed if provided the wood has been sourced from a sustainably harvested source. So
if I recall, Fabiano addressed that question at our recent MECLA working group meeting we had. And I think if I recall, his conversation around that was with a sustainable forest, or particularly with plantations, that when those trees are growing, that that carbon is stored in the roots and in bits that aren't used, but in effect, those bits, because the CO2 stored, will actually go back to the atmosphere. So in effect, that bit's carbon neutral. The bit of timber you take out of the stream and then store the carbon for the life of the product. So within the EPD, the EP is looking more at the carbon stored in the product, not in the physical tree when it was growing. So as I say, yeah, that carbon that remains stored in the stump and the roots, and there's a lot of carbon that stays there, and the branches and whatever that aren't used. If they aren't used, then that carbon is sort of assumed to go back to the atmosphere again.
All right, I got one last observation around all of this timber stuff. And as an architect and a developer and not a forestry guy, and Carl and I have talked about this, but if we really, as an industry, want to improve timber adoption for all the benefits that timber brings with, sequestered carbon, etc., and we look to not using old growth forests and reducing endangered species impacts, where do the supply chains see, and how long does it take to get a regular cycle of forestry supplied wood to better sort of prepare this industry for the future? Broad question, I know. You got 1 minute, and then I'll hand it over to Monica.
Can I just make a quick comment there? Thanks, Stephen. So I mentioned the field trips at the very end of my presentation. So we've held a couple of field trips recently, and we actually invited a group of architects, builders, and designers along, and a lot of them actually had never seen a sustainable forest management operation before, or responsible supply chains. And the feedback that we got post the field trip was overwhelmingly positive. So I'd encourage a lot of people that are actually asking questions out there as well to get in touch with me, and we're more than happy to take you out to the forest and show you what actually happens in the forest, show you a certified forest, show you certified chain of custody supply chains, and show you what actually happens in the forest. Unfortunately, there's a lot of misinformation out there, yeah, more than happy to, if you'd like to come onto one of our field trips, please come along. Love to have you along and show you what actually happens out there.
And I might just put some perspective at this conversation at the end, Stephen, also to remind people that if we're talking about engineered wood products, the bulk of those these days are coming from softwood resource and from plantation grown resources, particularly here in Australia. If we're talking about native forestry in Australia, it's important for the audience to also remember that an enormous amount of our forests are already in conservation reserves and national parks. It's part of the whole sort of RFA scheme that we have in place. So, by example, there's only about 6% of the forests that are available for harvesting at all, and only 1% of that is harvested in any 1 year. So it's about 0.014% of our forest areas is harvested in any 1 year from a native perspective, and all of it's regrown by law. So yeah, there's sometimes this assumption that all our forest is sort of being harvested, which is absolutely not true. So, but you're absolutely right, Stephen. The forest industry is absolutely behind ensuring that the use of these products is done in a sustainable and renewable way. And I'd have to say, I think it's probably implicit in Australia that we should be actually ensuring our supply comes from a local resource, not sort of expecting that it'll come from some overseas forest where we have no control over those environmental regulations. And that's exactly what will happen with Australian hardwoods, particularly if they're durable hardwoods. If we don't have local supply, the consumer demand will still continue. So it'll be coming from Borneo, Solomon Islands, New Guinea, Burma, those sort of countries. And we'd rather manage those things properly here, I would have thought.
No, I couldn't agree more. Look, we are on time. Look, I'd like to thank you all, gentlemen, here for your time, content, and myth-busting rigor today. And look, I will hand it over to Monica just to provide the close. Thanks again.
Thank you very much, everybody. Really great to hear the level of discussion, the complex question. We're all in our red peas as we're going through this journey together. And I love the idea, Matt, of people going on field trips to really learn more. I think we learn more when we go out together and see it together. So thank you, Stephen, for chairing. Thank you, Alistair, Matt, Tim, Carl Hein, and Stephen for your participation today. We know it's always a lot of time and effort put into working on these presentations together. Thank you, everybody. We had, I think, at peak 245 people on our webinar today. Thanks for joining us online and contributing. We'll have a recording of this on our website very, very soon, and you will receive an email from us for those who have registered. And you can also sign up to our newsletter to be informed about any new events and things that are happening. Also, thank you, of course, to our chair, Hudson Worsley, and Kati Beheran and Alexi Barnstone from Climate Kick. Together, we make all of this possible for our learning together. So our next spotlight event will be on the 5th of December. It'll focus on local councils and their roles in reducing embodied carbon. Remember that local councils put a lot of effort into building civil and linear infrastructure. Check out our socials and thank you all. Goodbye, and let's keep doing. Thanks very much. Bye for now.
Thanks, Monica.
Thanks,
Stephen.
Thanks, Monica.